In this video, I'll teach you how to train your YOLOv10 model with your custom dataset. I'll take you through from scratch and also teach you all the steps you need to follow to achieve this. I've also prepared a notebook I'll be sharing with you guys, so all you need to do is to bring in your data and run this notebook one after the other. I'll be sharing this notebook with you in the video description, so do check it out. Alright, so right here I'm on Google Colab, and this is a notebook I've prepared that we'll be using to train our custom YOLOv10 model using our own dataset. So you guys need to follow these exact steps in order not to run into any form of error. Make sure you watch the video to the end and follow all the steps so that you don't run into any form of error at all. Alright, so the first thing first, on Google Colab, all you'd have to do is to check your runtime and make sure you change this runtime to T4 GPU so that you can leverage the GPU provided by Google Colab, which is free of course. So you have to just make sure you've changed this runtime to the GPU, and right after doing that it will connect, and you can see a success tick mark here that you are connected to the T4 GPU. Alright. The next thing we have to do is to clone the YOLOv10 GitHub repository. So I've prepared this cell right here. So right here we are cloning the repository, and also we are installing the RoboFlow library because we'll be getting our data set from RoboFlow. So all you need to do is to run this cell, and this will go ahead and clone the YOLOv10 repository for you. So right after cloning the repository and installing RoboFlow, the next thing to do is to download the YOLOv10 pre-trained weights. Okay, so YOLOv10 comes with a lot of pre-trained weights, so you can download any of them to use, but in this case I'll be downloading all, and I'll use any of them I want to train my model on. So this will get downloaded, and it will download in a folder called -p. So I'll run this cell, and this will go ahead to download all the weights released so far for YOLOv10. So this is done, and when you open the folder side here, you can see we have our -q folder, and inside this -q folder we have all the pre-trained weights downloaded. Okay, so we can now go ahead and use this pre-trained weights to train our custom YOLOv10 model using our data. Okay, so the next step now, which is very crucial, is to download your data you want to use. In my case, I'll be using data from RoboFlow. So you just have to go to RoboFlow Universe, and when you go to RoboFlow Universe, make sure you sign up for RoboFlow account and log in. Then over here on RoboFlow Universe, they have 10,000s of data, already existing data that you can use. So you can see 500,000 plus data. You can just search for any data set at all and check if it is here. So in my case, I'll be doing fire detection, so I'll just search for fire detection and search for this. And over here you can see we have a lot of data sets for fire detection, but I'm going to go with this one since I want the training process to be very fast, and since this is a tutorial to teach you how to train your custom YOLOv10 model. So I'll click on this, and the next thing here is to click on download. So in order to download, you have to log in, so you can sign in with Google. This will load up, and you have to choose your account, click on continue, and this will go ahead and sign you in. So once you are signed in, you can click on download this dataset once again. Make sure you check the show download code radio button, and over here you can select the format. As at now, YOLOv10 format is not here, but you can go with YOLOv8, and after clicking on YOLOv8, just click on continue. So accept their terms, can continue once again. Okay, let me select the format. I'll continue, and all you need to do is to copy this code right here. So you just have to copy it, and we'll be using this in our Google Colab to download the dataset. So for every dataset you want to download, you just need to follow these exact same steps, and everything is going to work out. Okay, so after downloading it, you have to just sit here, but already I've done that, so you can see I have mine here, and in your case you have to sign up and do the same thing. Okay, so the next thing is to download this data set, and I can run this cell, and this will go ahead and download this data set and extract all the files I need for me. So this is how easily you can download dataset from RoboFlow by following this exact same step. Alright, so our dataset gets downloaded and it has been extracted. So when you open the side panel once again, you can see we have our fire detection 1 here, and inside here you can see we have our dataset. Okay, so we have our test, train, validation, and this right here are some file from RoboFlow that indicates that you have downloaded the dataset from RoboFlow. It doesn't matter. The main file also here is the data.yaml file. So this is the crucial part, guys. Make sure you do this. If not, you run into several errors while training this model. So click on the data.yaml file. This is going to open at the side panel. Over here you can drag it a little bit, and we are coming to edit the path to the train, test, and validation images. Okay, so now come to test. In your test folder, just click here and copy the path leading to your images. So copy path and come back here and just replace it, just paste it here. So this is now the new path leading to your images. You do the same thing for the train. So I'll just paste the same thing, and the only thing I'll change here is change test to train. Okay, the same thing for your validation as well. So I'll change the test here to valid, and that's it. So after that, you click on Ctrl S to save this back and you can close it. So that's a very crucial step in training your custom YOLOv10 model. You make sure you follow this exact same step. If not, you'll run into error, and you'll get a lot of errors trying to train this. Okay, so now we've modified the data.yaml file and everything is in a good shape. The next thing is to train this model. So you can see -YOLO, the task you want to perform here is object detection. So the task is detect, the mode is train, and epochs, which stand for the number of iteration, number of time your model sees your data. We specify 100, but I'll reduce this to 20, or let me make it yeah, I'll reduce this to 30. Let me make it 30. The batch size is 32. Plot is equal to true, and the model we want to use is YOLOv10. So over here, all you have to do is to go to your downloaded pre-trained weights, and you have to select the particular weights you want to train your YOLOv10 model with. So we've downloaded a lot of them, and in this case I'll be going with the nano version. So I'll just copy the path leading to this, and you have to make sure you paste that exact path here. So model, then you paste the exact path here. So I'm using the nano version. In case you don't want to use the nano version, you can use any other pre-trained weight we've downloaded. The next thing is your data. Okay, so that's why we've edited the data.yaml file. So you have to come right here, open the file detection dataset, and copy the path leading to your data.yaml file. Okay, and that's it. So you have to come and paste that same path in your data variable. So we have to paste the path here, content file detection data.yaml, and this is all you need in order to train your custom YOLOv8 model. Right from here, I can just run this cell and our entire training will begin. So guys, it's because it's tutorial sake, that's why I'm using 30 epochs. But in your case, if you are training for your model, you make sure you increase the epochs to a very big number, because the more the epoch, the better the model trains, and the better the model will be in detecting objects. Okay, I'm just using 30 here because it's tutorial and I want to show you guys how to train your model. Alright, so our training process has begun. It has downloaded the model weights and everything has begun. So it has started training, and we are at the first epoch, 1 out of 30. So this will go ahead and train your model, and it will save all this in a folder called runs. So you can see it has started logging the result to runs and detect. Okay, so guys, this will take some time to train. I will see you guys after the whole training process is done. Our whole training process is done. It's now testing it on our validation set, and that's it. So guys, the whole training process now is done, and you can see our results are saved in a folder called results, detect, and train. Okay, so you go back to your file system, you can see you get runs, and inside runs you have detect, and finally you have train. So all your results, your model weights, your F1 curve, your confusion matrix, and your weights are all stored here. Okay, so we can now download these weights and use, and I'll teach you how to access these weights right here in the code. Okay, so the next thing is to display our confusion matrix, and to do that I'm importing IPython. Okay, so from IPython I'm importing image, and also I'm importing YOLOv10 from Ultralytics so that we can use it to run tests on our test images. So I'll run this cell, and this should go ahead and import the necessary library. So now the first thing is to display our confusion matrix, and you have to go and copy the path and make sure you paste it here so that it can display it. So you go to your runs, and inside your runs you open detect. Inside detect you open train, and over here you can see your confusion matrix right here. So you just have to copy this path to the confusion matrix image and paste it here. So I've already set this path already, so it doesn't require me to do the same because it's in content runs detect train confusion matrix.png, and I've set the width to be 600. You can change it, it's dynamic. So I'll run this, and this will go ahead to show my confusion matrix, and this the confusion matrix. This is how the model performs. Also we can show the train results. Okay, so I can also run it. The path is being set automatically, but in your case make sure always you check where it is saved so that you can just go there and update this path anytime. But anytime you run the whole training process, another train folder will be created. In this case it's train, so the next time you run it, it will be train 1. You run it again, it will be train 2, and so on. So make sure you update this path accordingly. So since this is the first time we are training, it remains train, and this is the results, our metrics. Okay, so these are the results. You can check it out. We didn't train for that long, so we didn't expect it to be that smooth. All right, so the next step is to test this model on the test set. Okay, so in the data set we've downloaded, we have the test set right here, and we have to test these images on the test set. So you come to test images and make sure you copy this path beforehand, because we use it to assess all the images and see how the model performs on these images. Okay, so over here you can see I'm specifying the path to the model I've trained, which is our weight. So right here our weight will be in the runs folder, the text, and over here you can see we have weights. Okay, so you get two weights by default when you are using YOLOv10, the best.pt and the last.pt. So the best.pt is your best performing model, so always you have to use this. So you have to copy the path to your best.pt, and you have to paste it right here to your model path variable. So I've already set that up. You have to just run it and everything will be done. Okay, so this is a path to our best performing model called best.pt, and also we have instantiated the YOLO model here, so YOLOv10, and we are passing in our model path to it so that we can now run inference. Okay, so over here I can just go ahead and run this, and this will load in all our test images and run the inference on them. So you can see the source here, I'm specifying the test images. Okay, that's the path to all my test images, and I showed you where the test images are. I'll run this again. The test images are in the fire detection one, and over here we have test. When you open it, you have images, so you can use these images to test your model. You can copy the path, and that's what I have done already. Make sure you paste that same path right here. Okay, so it has run inference on all the test images, and now what you have to do is to visualize all these test images, and then we can see how the model tries to detect the fire in the images. Okay, so because there are many, I'm trying to use a glob here. So glob is a Python library that helps you to maybe open some directory and list all the images right there. So I've imported glob, and I've specified a variable here called images, and that we use glob.glob, and over here you show the path to your images. Okay, and make sure you bring this asterisk here, and also you put the extension of your images. In my case, the extension for all these images are JPG. As you can see here, you can see they are all JPG, so you have to put the extension name here so that you can grab all the images in that particular folder for you. Right after doing that, the next thing I went ahead to do is to iterate through all these images and then display them using IPython library. So when I run this, this should go ahead and list all these images out and show me how the fire is being dictated on them. So you can see a lot of images, and this has done a very good job considering the fact that we've only trained for 30 epochs. It has been able to detect both the smoke and the fire so well. Okay, so this is doing a good job. And here is it. We are detecting fire. So I think pretty much it has detected fire in all the images. Despite training for only 30 epochs. So I think this is a nice model, but I suggest training it for some extra epochs in order to have full confidence about your model. Okay, so the localization is good. It has done a great job, and you can see a lot of images. Yes, still it has detected everything in it. Okay, guys, so you can see how simple it is to train your custom object detection model using YOLOv10 and your own data set. I think I can just scroll down because there are a lot of them and it has detected it so well. Okay, so the next step is to run inference on a video file. In case you are having a video file, you want to run inference on it. It's the same thing. You initialize the model path, which we have done for the images. And over here, all you need to do is to place your video file here. I'm not having a video file of fire, so I just write the code for you so that you guys can just replace here with the path to your video file. If you want to upload your video file to Colab, you just have to drag and drop it right here and it will upload. Then after that, you can copy the path and just put it right here and run this. And this is going to run inference on the video file, and at the end of the day, it will give you all the detections in the video file, and after that you can download that video file and view it on your machine. It will also show you where the video file will be saved. You can just open that directory and download that video file and you will use it. Okay, so guys, this is all for how to train your custom YOLOv10 model using your custom data set as well. If you have any questions, make sure you leave it in the comments for me. Any other videos you want us to make on YOLOv10, don't hesitate to leave the comments because that is kind of helpful. So I'll be sharing the notebook with you once again in the video description. So do check it out and also use it yourself to train your custom YOLOv10 model. Make sure you share your results with me as well in the comment section and let's see how it goes. Thanks for watching once again, and as usual, I'll see you in the next video.